Bring it back.
Hello and welcome to another video. Today video is about galaxy. What is a galaxy? All you need to know. What is a galaxy? A galaxy is a vast island of gas, dust and stars in an ocean of space. Typically, galaxies are millions of light years apart. Galaxies are the building blocks of our universe. Their distribution isn't random, as one might suppose. Instead, galaxies are long, unimaginably long filaments across the universe, forming a cosmic web of star cities. A galaxy can contain hundreds of billions of stars and be many thousands of light years across. Our own galaxy, the Milky Way, is around 100,000 light years in diameter. That's about 587,900 trillion miles, or nearly a million trillion kilometers. The three types of galaxies are spiral, elliptical, or irregular. Galaxy sizes vary widely, ranging from very small to unbelievably enormous. Small dwarf galaxies contain about 100 million stars and giant galaxies contain more than a trillion stars. Also, there are an estimated 200 billion galaxies in the universe. In 2016, using 20 years of images from the Hubble, it was estimated that there were in total 2 trillion or more galaxies in the observable universe. In 2021, data from NASA's New Horizons space probe was used to revise the earlier estimate to roughly 200 billion galaxies. The discovery of other galaxies. The famous astronomer Edwin P. Hubble first classified galaxies based on their visual appearance in the late 1920s and 30s. In fact, Hubble's classification of galaxies is still widely used today. Although, since Hubble's time, like any effective classification system, it's evolved in light of ongoing observations. Hubble used several basic types of galaxies, each containing subtypes. Spiral galaxies are more mysterious than we thought. At Karel Masters, at Bruges and hundreds of thousands of volunteers at Galaxy Zoo have shown that the Hubble tuning fork method of categorization is wrong. Before Hubble's study of galaxies, we believed that our galaxy was the only one in the universe. Astronomers thought that the smudges of light they saw through their telescopes were in fact nebulae within our own galaxy. However, Hubble discovered that these nebulae were galaxies. Additionally, it was Hubble who demonstrated, by measuring their velocities, that they lie at vast distances from us. These galaxies lie millions of light years beyond the Milky Way, at distances so huge they appear tiny in all but the largest telescopes. Moreover, he demonstrated that, wherever he looked, galaxies were receding from us in all directions, and the further away they are, the faster they are receding. Thus, Hubble had discovered that the universe is expanding. Spiral galaxies. The most common type of galaxy is a spiral galaxy. The Milky Way is a spiral galaxy. Spiral galaxies have majestic, sweeping arms, thousands of light years long, made up of millions upon millions of stars. Their spiral arms stand out because of bright stars, glowing gas and dust. Spiral galaxies are active with star formation. Also, spiral galaxies have a bright center, made up of a dense concentration of stars, so tightly packed that from a distance the galaxy's center looks like a solid ball. This ball of stars is known as the galactic bulge. Also, there are two types of spiral galaxies. There are regular spirals and barred spirals. If the spiral has bars, they extend off the central bulge. Then, the spiral arms start at the end of the bar. Elliptical and irregular galaxies. Elliptical galaxies are the universe's largest galaxies. In fact, giant elliptical galaxies can be about 300,000 light years across. While the dwarf elliptical galaxies, the most common elliptical, are only a few thousand light years across. There are several shapes of elliptical galaxies, ranging from circular to football-shaped. Overall, 1/3 of all galaxies are elliptical galaxies. Elliptical galaxies contain very little gas and dust, compared to a spiral or irregular galaxy, and they are no longer actively forming stars. The stars in elliptical galaxies are older stars and contain very few heavier elements. Irregular shaped galaxies have all sorts of different shapes, but they don't look like a spiral or elliptical galaxy. Irregular galaxies can have very little dust or a lot. Plus, they can show active star-forming regions or have little to no star formation occurring. They seemed plentiful in the early universe. Our Milky Way galaxy. The Milky Way, in fact, falls into one of Hubble's spiral galaxy subtypes. It's a barred spiral, which means it has a bar of stars protruding out from each side of its center. As the spiral arms sweep out in their graceful and enormous arcs, the ends of the bars are the anchors. This is a recent discovery and it's unknown how bars form in a galaxy. Our solar system is situated about 2/3 of the way out from the galactic center towards the periphery of the galaxy, embedded in one of these spiral arms. Another recent discovery is that the disk of the Milky Way is warped, like a long-playing vinyl record left too long in the sun. Exactly why is unknown, but it may be the result of a gravitational encounter with another galaxy early in the Milky Way's history. It also appears that all galaxies rotate. For example, the Milky Way takes 226 million years to spin around once. Since its creation, the Earth has traveled 20 times around the galaxy. Galaxies come in clusters. Galaxies group together in clusters. Our own galaxy is part of what is called the local group, and it contains roughly 55 galaxies. Ultimately, galaxy clusters themselves group into superclusters. Our local group is part of the Virgo supercluster. The glue that binds stars into galaxies, galaxies into clusters, clusters into superclusters and superclusters into filaments is, of course, gravity. In fact, gravity is the universe's construction worker, which sculpts all the structures we see in the cosmos. Galaxies are flying apart. Although most galaxies are flying apart from each other, those astronomically close to each other will be gravitationally bound to each other. Caught in an inexorable gravitational dance, eventually they merge, passing through each other over millions of years, eventually forming a single, amorphous elliptical galaxy. Gravity shockwaves compress huge clouds of interstellar gas and dust during such mergers, giving rise to new generations of stars. The Milky Way is caught in such a gravitational embrace with M31, aka the Andromeda Galaxy, which is 2.5 million light-years distant. Both galaxies are moving toward each other because of gravitational attraction. They will merge in about 6 billion years. However, both galaxies are surrounded by huge halos of gas which may extend for millions of light-years, and it was discovered that the halos of the Milky Way and M31 have already started to touch. Galaxy mergers and companion galaxies. Galaxy mergers are common. The universe is full of examples of galaxies in various stages of merging together, their structures disrupted and distorted by gravity, forming bizarre and beautiful shapes. Then, at the lower end of the galactic size scale, there are so-called dwarf galaxies, consisting of a few hundred to up to several billion stars. Their origin is not clear. Typically, they have no clearly defined structure. Astronomers believe they were born in the same way as larger galaxies like the Milky Way, but for whatever reason they stopped growing. Ensnared by the gravity of a larger galaxy, they orbit its periphery. The Milky Way has around 20 dwarf galaxies orbiting it that we know of, although some models predict there should be many more. Our closest neighbors, the Magellanic Clouds. The two most famous dwarf galaxies for us Earthlings are, of course, the small and large Magellanic Clouds, visible to the unaided eye in Earth's southern hemisphere sky. Eventually, these and other dwarf galaxies will rip apart under the titanic pull of the Milky Way's gravity. This will leave behind a barely noticeable stream of stars across the sky, slowly dissipating over eons. Supermassive black holes lurk in galactic centers. At the center of most galaxies lurks a supermassive black hole, of millions or even billions of solar masses. For example, Ton 618 has a mass 66 billion times that of our Sun. The origin and evolution of supermassive black holes remains a mystery. A few years ago, astronomers uncovered a surprising fact. In spiral galaxies, the mass of the supermassive black hole has a direct linear relationship with the mass of the galactic bulge. The more mass the black hole has, the more stars there are in the bulge. No one knows exactly what the significance of this relationship may be. However, its existence seems to indicate that the growth of a galaxy's stellar population and that of its supermassive black hole are inextricably linked. This discovery comes at a time when astronomers are beginning to realize that a supermassive black hole may control the fate of its host galaxy, The copious amounts of electromagnetic radiation emitted from the maelstrom of material orbiting the central black hole, known as the accretion disk, may push away and dissipate the clouds of interstellar hydrogen from which new stars form. This acts as an inhibitor on the galaxy's ability to give birth to new stars. Ultimately, the emergence of life itself may be tied to the activity of supermassive black holes. This is an area that is undergoing extensive research. While astronomers still know very little about exactly how galaxies formed in the first place, we see them in their nascent state only a few 100 million years after the Big Bang. The study of galaxies is an endless voyage of discovery. We discovered other galaxies exist less than a century ago. Less than 100 years after we realized that other galaxies exist besides our own, we have learned so much about these grand, majestic star cities. And there is still much to learn. Bottom line, a galaxy is a vast island of gas, dust and stars in an ocean of space.